In order to fully appreciate and grasp the essence of value stream mapping, we will be presenting a case study. We will use value stream mapping as a technique to follow one of 12 processes within a system for a company called mock company. After each stage of our presentation with the mock company, we will stop and apply the new knowledge to Skyview Airplane Company. We also like to refer to this exercise as the Lego simulation.
We will now begin our case study. Before we can develop an action plan, we will need to draw a current state map. This is our foundation for the future state. We begin drawing our map by working backwards through the system. We begin with the customer. As we create the map, try and observe ways in which material and information flow. Material flow identifies the movement of physical product through the value stream. Information flow shows sources of data that tell a process what to do or produce. Be mindful also of the material transformation process, in which raw materials are transformed into subassemblies and eventually into the final product. The mock company has a customer. This is identified in our map by using a material icon that represents an outside source. This type of icon can be used to show a customer, a supplier, or an outside manufacturing process. The customer demand presently is 1,000 pieces per day. This is identified by another material icon used to represent the truck shipment or shipments. The text on the icon notes the frequency of shipments. The arrow is also a material icon. This particular arrow is used to represent movement of finished goods to the customer. The customer sends in daily orders and they are processed. This series of boxes represents the flow of information as related to these orders. Each of these boxes is an icon that represents a particular manufacturing process. One process box equals an area of flow. All processes should be labeled. The boxes are also used for departments, such as production control. In our case study, the orders go through order entry, then production control, then planning, and then materials. The zigzag arrow here is an information icon and represents electronic information flow. For example, via electronic data interchange, or EDI. The straight arrows are information icons that represent manual information flow. For example, a production schedule or shipping schedule. In this next part of the process, the materials group sends weekly purchase orders to the steel supplier. This top row of icons represents some of the basic information flow as related to a particular product or product family. What we are going to do next is follow some of the material flow in the plant. From left to right, we have the various manufacturing processes: stamp, press, weld, assembly, and shipping. The operators for each process are represented by this icon, implying that a person is being viewed from above. Each operation has one person, except for assembly, where we see 2 people are needed. The arrow in this case is a material icon representing movement of production material by push. This means material that is produced and moved forward before the next process needs it. This is usually based on a schedule. The triangular icon represents inventory between each of the operations. The inventory count should be noted. When we walked the process in the mock company, we found the count between the processes. Between stamp and press, we have 1,500 pieces. Between press and weld, 1,750 pieces. Between weld and assembly, 2,000 pieces. And between assembly and shipping, 2,000 pieces. The steel supplier is shipping weekly. The truck shipment is 2 coils. Each coil represents 1,500 pieces. Data boxes are used below each of the operations to record information concerning a manufacturing process, department, customer, etc. The next step in our case study is to gather the data for each of the operations. We want to include as much meaningful information as we can find in these data boxes. Let's focus in on the data box for the stamp operation. Cycle time specifies how frequently an item or product is completed by a process, as timed by direct observation. It also means the time it takes an operator to go through all of his or her work elements before repeating them. Changeover is when a piece of equipment has to stop producing in order to be fitted for producing a different item. For example, the installation of a different processing tool in a metal working machine, a different color paint in a painting system, a new plastic resin and mold in an injection molding machine, loading different software, and so on. Changeover time specifies how long this takes. The third piece of information in this data box lets us know that we are running one shift. The yield lets us know what percentage of our material is being produced into a usable product or product family. This implies that whatever is left over is discarded. Generally, we refer to this discarded material as scrap. As we compare the data across all of the operations, we make the following observations. The cycle time for stamp equals 1 second, press equals 10 seconds, weld equals 20 seconds, assembly equals 45 seconds. The changeover times are stamp equals 90 minutes, press equals 30 minutes, weld equals 30 minutes, and assembly equals 30 minutes. The yields are stamp equals 85%, press equals 100%, weld equals 90%, assembly equals 100%. At this point, we note that planning gives a weekly schedule to stamp, press, weld, and assembly, which is adjusted daily. This is represented here by an information box icon and some manual information flow arrows. The mock company does some daily expediting, where they gather information from each of the operations. They check inventory levels and adjust schedules. The little glasses are an information icon that represents Go See production scheduling. This information is fed back to production control and then planning, as indicated by the dotted arrows. And then the schedules are adjusted. This graph along the bottom looks at production lead time. Lead time is the time required for one piece to move all the way through a process or value stream, from start to finish. Envision timing a marked item as it moves from beginning to end. By looking at this graph, we can determine time spent on value-added and non-value-added activities.